Welcome to the second episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. In this episode, I'll be talking with Adam Kersnowski, co-founder and chief evangelist at AirWorks. Adam has been involved with drones and construction for more than 15 years. Prior to co-founding AirWorks, he was a successful founder, owner, and manager of 2 companies. As chief evangelist, Adam leads client success, account expansion, as well as business development and partnerships. He has a passion for all things data collection and remote sensing. In this episode, I'll be talking to him about how firms can get started with new technology and tools and the power of AI in the AEC industry. All right, let's jump into today's episode. All right, it's now time for our conversation of the week with Adam Kersnowski, co-founder and chief evangelist at AirWorks. Adam, great to have you here today. I briefly introduced you, but in your own words, can you please tell our listeners about yourself and what you do on a daily basis?
Sure. I'm one of the founders of AirWorks Solutions, Inc. That's what I always kind of lead with. For me, that's one of the most important titles that I can have, just because this the nature of what I like doing is building and growing businesses. So outside of AirWorks, right, there's been some in the past as well, but currently my title is chief evangelist. It's kind of changed a few times over the course of this company, just depending on needs. But as a chief evangelist, I'm out in the world spreading the word about AirWorks, but also bringing that passion along with it. So currently I'm sitting in a hotel room in Boise, Idaho, getting ready for the GIS Pro conference. So with evangelizing about AirWorks, our product, what we do, right, I'm heavily working with our sales, our customer success teams. I run a lot with business development and partnerships. That's the majority of what I do for AirWorks, but just is really making sure that we are building the products that our clients, that this industry really want. So there's no better way than just to be with people out here in the world.
Agreed. And it's always great to see the founders stay connected to the products, kind of true to their vision and, constantly getting that customer feedback and updates, et cetera. So great to see that you're still involved in the day-to-day, of course. But for people who might not be familiar with AirWorks, can you tell us what AirWorks is and what kind of businesses you guys support?
Sure. So we are what we call a SaaS business, so software as a service. The core of our software is our AI, or machine learning, is a better way to even describe it. But we develop algorithms to extract the features that an engineer or surveyor or plenty others would want to pull from imagery and point clouds. So it is automating what was a very time-consuming process at tracing over imagery to build a base map for a lot of different purposes.
And speaking from experience, Adam, I have been the one to trace over those base maps, so I understand how tedious and time-consuming it can be. So that's awesome. And here at EMI, we really are focused on civil engineering professionals and bringing value and content to them. So of course, this is right in their wheelhouse. But speaking of those E professionals, the engineers, what do you think AEC professionals need to be aware of regarding upcoming trends in the industry?
Yeah, I mean, it's a good question, right? It's technology advances so quickly, right? So and not just the processing for what we do, but also the tools, the hardware for the collection. And that's what we look at a lot, right? Just from research that we've done in the past, we know that the amount of imagery that's collected right now is going to double in just a year, right? So if we're collecting petabytes of imagery and point clouds at this point in time with our sensors, that just doubles, in just a short period of time. And for the engineers that are out there, right, that kind of signals something. This is maybe like to hit a heartstring of data overload, right? So how can our current companies and employees or staff support the amount of data that we're seeing now and what we're about to see in the future? So making sure that we're, I think, in line with the tools that are being used in the field and how we can manage the data sets further downstream is incredibly important. So unfortunately, right, there's challenges around our labor force right now, and the amount of work on our tables right now is already a bit overwhelming, and you just exemplify that by the advancements in the tools that can collect more and more data. It kind of just starts to create this big bottleneck. So yeah, making sure that we're up with the technologies can help manage all of that, I think, is the most important piece.
Agreed. And, speaking from my own experience, Adam, it's been very interesting to see, how different companies utilize technology and their stance on how it might be implemented in their workflow. So if you're talking to an employee, right, who's interested in AirWorks or really any software, what advice do you have for them regarding the implementation of new technology? Like, what should they be looking out for, and how should they be making that use case to a decision maker in their firm?
Yeah, well, I think we study this actually a lot, right? Because we want to be targeted as a company at who we talk to, who we start to have conversations with, because you have the user, right? The person that is going to be using the product. Let's say a project manager, or let's say a drafter. But then you have the decision maker who cares a lot about the business side of it, right? So I mean, I would say it's pretty standard, right? When you're looking at a new technology, right, you have to look at what that return on investment is going to be, right? If we spend a certain amount of money on a technology or a tool, right, what will it actually produce for the returns? And also making sure that it's effective, that it actually works, right? So I think going through a regimented proof of concept process, regardless of what software or hardware it is, I think is super important. A lot of times the data sheets that you see out there to back up a technology might be well, I wouldn't say it's fabricated. That's not where I'm going with that. But it is sometimes done in a laboratory kind of setting where you have ideal conditions. And we know the world is not like that. So I think testing something on a real project where you can really stack it up against the way that a process is currently being done is a really good way to see a technology compared to maybe a traditional means.
Agreed. And I've been through a number of extensive proof of concepts. And what I've learned is it really is the only way to understand if a technology applies to your specific business use case. And I'm just going to assume, and correct me if I'm wrong, but your representatives that are working with your customers can help build that use case specific to their company, right?
Absolutely. Yeah. One of the big things that we do when we go through proof of concept is, first of all, make sure that a company is ready to work with, right? Sometimes we might get distracted even as a company because somebody wants to talk. Somebody else is excited about what our technology does, but when you get down into the weeds a little bit, they don't fly drones, or they don't use manned aircraft imagery, or they don't have scanners even. But so there's not a good fit. So first of all, we try to make sure that there's a good fit. We need to make sure that the companies that we're working with are producing the data that we could actually process. But when we go into a proof of concept, we lay out success criteria. I think that is the most effective way to do this because it sets expectations in the right at the right level. If a company is only concerned about speed, right? We want to go through a proof of concept that highlights the speed of our deliverables, pricing, or let's say quality, right? Quality is also a very big one, and accuracies, that type of thing. So laying out those things in detail and then running the proof of concept and measuring back to that is the most important piece of that proof of concept.
Absolutely. So then, all that being said, we can back up a step here. Is if you have a firm that comes to you and says, "Hey, we are not very technologically advanced. Something like AirWorks is completely new to us." Where are you getting them to start? Is it that proof of concept, or is there another piece to this?
Yeah, usually we have a bit of discovery, right? It's a conversation like you and I had before this, like, catching up, just seeing what's going on in the industry, but then really kind of pinpointing where the needs are, maybe where there are current bottlenecks. Sometimes clients already know where their bottlenecks are. Sometimes clients don't know where their bottlenecks are. So it's discovering those types of things. And we're exploring what sensors are used really before data even gets to us. The workflow, right, is pretty standard, right? There is some sort of data collection, right? So you have sensors and planning of those missions. Then you have post-processing, and there's softwares that manage post-processing, especially if it's in with photogrammetry or even LiDAR. And then after that, that's usually when the data sets come to us. And so we really need to get a better understanding with our clients of what tools they're using, what software they're using beforehand. And then also after we do our classifications and extractions, we also want to know where is the data going to, right? Is it going into a CAD environment? Is it going into a GIS environment? Because we want to be able to make sure that our deliverable does not interrupt a workflow for a company. So we want to streamline our process, and just getting a better understanding of where data is coming from and where it's going to certainly helps us understand and lay out that proof of concept even better.
And two things about that stood out to me, Adam. One being data, and two being the bottleneck that a lot of firms are facing. So pretty much in every industry and every market, there's talk of AI or artificial intelligence. Could you talk a little bit about like what is the power of artificial intelligence in AEC? What kind of efficiencies should people look for? And like what types of use cases is AI good for?
Yeah, well, you might have to remind me of the latter part of that question, because just the first part, there's a lot to talk about there alone. AI is obviously a term that's used wildly, right, across a lot of different industries. And I think for us, you got to break it down even a little bit further, right? So you have AI, you have machine learning that sits under that, and then you have deep learning, which sits under that. And us as a company, we live in that deep learning space, right? So we're looking at imagery, right? You could think about ortho imagery more particularly, right? So as an aircraft or a drone or even sensors on the ground collect data, they might have individual images that get stitched together, right? So we look at this big ortho image, we break it down into tiles, we break it down into pixels, and we start to assign those pixels with an RGB value, right? So it goes back to math. At the end of the day, it's all math, right? We're assigning pixels, RGB values. The deep learning models only look at those RGB values. So for instance, if I picked up one pixel from the screen I'm looking at, like let's say at your hairline, since you have a nice hairline, I'll pick on that. But we look at, it could be R56 and green 243 and B 150, right? Those are just numbers. And so what the deep learning model is taking is looking at those values, and it's starting to recognize patterns, right? So we're very much interested in edge detection. So the edge of features like edge of road or an edge of a sidewalk or an edge of a tree canopy. So we need to start to look at the color values in those pixels and sort of the hierarchy of where the edge of a road would be next to a curb or where that curb would be next to a sidewalk. So it's really just making sense of the patterns in those pixels, and really it's just a lot of math that happens deep in these models.
And as you work with your customers, do you feel that, as let's say you get some sort of unique site civil feature, may not necessarily have worked on it before, but do your algorithms and the technology get better at exactly what you talked about over time?
Yeah, that's the most important piece of what we do. In fact, it's some of the most challenging work, which is done ahead of time. So when we launched this company, we spent many years building up this data moat, and that data moat was really the training or the data that would allow us to train the algorithm properly. So we would call that ground truth almost. It's a little different than what a surveyor or let's say a photogrammetrist would call ground truth, but this is how the ground truth is how we want the model to perform at the end of the day, right? So we have to have a really robust data set that looks like the ground truth that we want to inference. And sometimes at the very beginning of when we start this, we have really bad predictions. Lines are not straight. They don't capture all the features. And it's the correction that we make to that allows us to, first of all, deliver that to our client standards. But then we actually reuse that data to train, or the corrections to retrain the model. And that's incredibly important. That's the only way this thing learns and gets better. If you just kept feeding it data without they call it back propagation, right? Without that process, then you're never going to improve that model. That's the learning aspect of it. So as a company, we actually retain the rights to use the corrected vectors that we create to learn the models, as you would say. And of course, our clients are all involved in that process. It's a win-win for us both. We produce better predictions at the end of the day. That means better turnaround times. Eventually, we can lower costs. That's something we would love to do, and pass that on to our clients. So our clients are very much involved in this process. So the feedback, even after we run a data set, maybe even after delivery, because we know we don't deliver 100% of all features, right? We have a core layers that we are very focused on training to perform better, and we'll build onto those layers as we grow as a company. But there are many things that our firms have to do outside of what we do. So we are very interested in looking at that. So how do they, even after we deliver a project back to them, how do they add to it or remove things that can also feed into that that training process as well.
Absolutely. And speaking of that human input, one thing that I really liked when my company did a proof of concept of AirWorks was that human involvement you guys have on the back end, right? Because like I always say, AEC is very relationship and human based. So it's good to know that even with the amazing technology that you guys provide, there's still that human touch. Could you talk a little bit about how humans are involved at the back end of the process?
Absolutely. Yeah. So when our clients run or push a data set on our platform online, this is, by the way, we're stacked on AWS. So they're bringing data with a TIFF, a GeoTIFF, or a point cloud. It could be photogrammetric or LiDAR. Bring that into our software. When they hit that process button, this is what kicks off, of course, the core of what we do, which is our machine learning, right, for the extraction piece. That gives us a prediction, also could be called an inference. And that prediction, like I mentioned before, is not always the best, right? So we might capture, let's say, 98% of a building with a mask and a vector, but is that vector really straight? Does it have only 4 nodes on the corners of the buildings? That's the usability side that we have to have the human help correct too, right? So we do have processes or automation. I wouldn't call it AI, but automation that takes that inference and it reduces nodes, and it snaps lines, let's say edge of driveway to road, right? It snaps lines to lines, removes nodes, that type of thing. Dongles on some of the vectors as well. So after that, we're going to run this through a human in the loop, right, to do that final QC. We might see features, or we might have features that the AI just didn't pick up. Let's say a manhole in a deep shadow, or there are no data regions, or there are artifacts around certain objects where we can't extract things. So we'll certainly we'll want to recognize that. It's good for our clients to actually get that feedback too, right? Of these of the challenges that we see in the data, even, right? That affects the performance of the model. And so, yeah, so once the human is done QCing that, that is what's delivered back to the client. And then we, of course, turn that into the training data afterwards.
Absolutely.
Yeah.
And, with all of this talk about AI and kind of the progression that appears to have been put on super speed in the last couple of years of construction technology, AI in particular, people often fear that AI is going to replace jobs. Can you talk to us about some of the common misconceptions about AI, but more generally implementing new technology?
Yeah, this is age old, right? This happens for hundreds and hundreds of years, actually. I watched a piece recently during our history, right, of times where automation. So when we made the switch from horse-drawn carriages to combustion engine vehicles, right, there was a fear that it was going to displace an entire industry. Not obviously the horses were affected, but there was an entire industry behind that was affected, right? But it didn't remove or didn't get rid of people or replace people. It just redistributed people. People went into other industries or other learned new skill sets, right, that would support what we're doing. And that's the way I kind of look at it. It is not replacing jobs. It's actually creating a better work environment, to be honest with you, right? It's a tool that's used in a process, right? And we are constantly hearing from every single one of our clients, and when I'm out here at these shows, they talk about labor shortages in the survey industry and the engineering industry. So you can't say out of one side of your mouth that we have this labor shortage, and then out of the other side say we're worried about technology and AI replacing jobs, because those two obviously are contradicting. So there's I think what needs to happen, not to say or beyond just the whole replacement of labor, is also people have the fear of knowing what happens in that the machine learning process, right? The traceability is, why did an algorithm make a decision, right, to put a mask and a vector on a certain object, right? And it's really the traceability to that. I think as an engineering professional, right, that is important for a lot of different reasons. Liability, right? When a bridge or a road is constructed off of somebody's design, right, where did that design come from? Well, if we helped create those base maps and extracted features that went into a design, we just have to be methodical on how we trace what decision was made by the algorithm, but then also how it was changed afterwards by us as humans, right? And just having that alone should bring comfort to people, because they can always go back to it and see where that data or that decision was made.
And and it's not an apples to apples comparison, Adam, but going back to that, just this general bridge project you mentioned, right? There was a structural engineer who likely has some sort of analysis model based on a software package to design that bridge, right? And it's the
Yep.
same, it's the same thing we're taught in our undergraduate coursework, is garbage in, garbage out, and understanding, how the software is working, which in our case, a couple back of the napkin checks, equations, et cetera. So I agree that traceability is very important. And, you did touch on the labor shortage. So how do you think the labor shortage in our industry in particular is going to affect individuals' inclination to seek technology or learn new skills?
I think it's going to drive people to technology, right? If you're having you're a project manager and you are finding a challenge to find labor to complete your project, right? There's no other way to look at technology, right? The other option is you hinder business growth, and nobody wants that, right? So it is it is really, I see as the only option. You know, there's only so much we can scale, right? With humans, but we can enhance what that person does in their day to day.
Absolutely. And Adam, that's exactly the reason why we started this podcast, because in AEC, the E in particular, there's just such a lack of a resource for companies to turn to say, I know I have a problem and I think technology might be able to solve it, but where do I turn? And, you know, speaking specifically in civil and infrastructure, could you talk about AirWorks application to the civil engineering profession and infrastructure markets in particular? And let's just say, you know, maybe give an example of a project that would be a good use case.
Yeah, I mean, one use case that I think is very important right now is because they're big scale, right? I think scale is a key factor here. So long linear corridors, whether it's highway or it's just roads in general, right of way types of surveys or types of work that's needed to understand what existing conditions are, or even to produce the permit drawings or the permit documents needed for the construction work, is a perfect application. So you're taking, you know, 1,000 miles of road, center of road, 60 feet on either side, and extracting the features that lie within that right of way. So that would be paint markings and edge of road and curb and vegetation, sidewalk. You know, there's the list goes on from there. But it is whether it's on a highway or if it's on a rural road where fiber optics is being installed and they need to create permit drawings for or permit or achieve permit documentation. That's a great application. I don't think AirWorks is the best source for let's say work on bridges or vertical type structures. You would think of us more as like sort of on the ground, civil, kind of sprawling projects. I maybe bring it back to just the bridge topic. If you have to produce existing conditions, if there's some sort of easement or setback of existing conditions that need to be gathered around the bridge, we could help, right? So if you have to go up, certain footage away from the bridge, we could certainly help in that extraction. But it's not necessarily. We're not geared towards extracting bridge members and that type of thing.
Which is a good point to bring up, right? Because there are different types of technology. LiDAR, you had mentioned earlier, right? Could be a really good use case to start, say, sizing, box beams, girders, et cetera, on a bridge, right? Maybe not AirWorks specialty, but the technology is out there, and we'll likely cover some of those at some point in the future to our listeners here. But could you give some examples of sensor data that you guys would take in from a client to then essentially do everything you just spoke of?
Absolutely. I'll start on the ground and then I'll work my way up into the sky. So on the ground, we work with a whole host of mobile sensors. So it could be from Navis, it could be from LiDAR USA, it could be from Regal, Leica, Trimble, right? Any of those sensors that are collecting data in a mobile application. So driving corridors with these sensors sometimes it's hard to fly actually with a drone because of the restrictions around FAA, or it travels into no-fly zones, right? So you might want to use that mobile scanner. But we would extract that a right-of-way or the features in that side, that right-of-way for that type of application. Now you move up to the drone. So a whole host of aircrafts that can carry a multitude of different sensors. Those could be a lot of cameras, different cameras, also a lot of different LiDAR sensors that can be flown on those UAVs. And you know, for that use case, right? The resolution that those cameras can produce and the point cloud densities that those sensors can produce is a really good fit for our company as well. And then stepping up one more level to manned aircraft, you know, the resolution changes a little bit. So you might not be able to do as detailed work as, let's say, UAV or mobile projects, but with manned aircraft, there are certain features that are more in alignment with that resolution band. And again, those could be imagery sensors and LiDAR sensors as well. Then there's one more level or a couple more levels. We're starting to work with stratospheric balloon companies. That's really interesting. And then even one more up from that would be moving into space with satellites. We've certainly run data sets there. I don't think we're ready for go-to-market in the satellite space yet, but we're certainly preparing ourselves for that.
Awesome. And it's great that you guys have such a wide variety of sensor availability because, you know, in my experience, right, that manned aircraft, obtaining the imagery is actually not that expensive, but it can provide great returns, particularly if you need to say, just need some sort of base set of plans to then go out in the field with, make some marks, perhaps add some extra sensor data and tie it to specific locations. That can actually be a really good way to get started for not that much cost up front and get your process moving faster. So good to know that there are a lot of options when it comes to working with AirWorks. But I guess then my final question for you today, Adam, would be, do you have any final piece of advice you'd like to give our listeners, particularly regarding just, you know, getting started here with technology?
Yeah, I think you asked a couple questions earlier just about AI in general. I think sometimes the pushback we get from companies is because of what they've heard, right, in other areas of AI, and it's kind of painted with, I think, sometimes a bad picture, right? I would suggest, you know, looking at it from a different mindset, right? To me, the type of AI that we developed for this company is complicated, but it's math, right? At the end of the day, and for somebody to push back on that, it is I don't know. Sometimes it's an area that I wish people were a little more open to giving that a chance. And we can certainly set up measures to again for us to show how decisions were made and the traceability, because once you have that the comfort in what we're producing, there's technology will be the only way that we're able to scale our own business, of the businesses that we run and properly. I don't see any other way around it.
Agreed. And I think you've hit on two important points. One being, you know, just quality of life, right? If you can have your engineer actually doing engineering instead of tracing over a base map, right, and letting AirWorks handle, let's call it, you know, the grunt work that's important and necessary, but isn't always the most glamorous or exciting, right? And then the second, I think, is just education, helping your clients to understand like what's behind your product and maybe clearing up some of those misconceptions. But Adam, you know, thank you for joining us today. We really appreciate it, particularly as we're getting the podcast kicked off here. But how can our listeners connect with you? Are you on, you know, social media, or where's the best place for them to find you?
Yeah, definitely on LinkedIn Adam Kersnowski, or AirWorks. You search any of those, you'll find me. My email address is adam@airworks.io. Feel free to reach out to me by email. And then our website, we've got a lot of great content online, our product page, our industry pages, and from there you can get a lot of good content. If you want to learn a little bit more about how our AI works, we have an AI ebook. We have a ton of blogs there that you can poke around at. And if you think that it's a good fit, there's a place where we can sit down and do a little discovery. So I can't say it'll always be with me, but we have an amazing sales team that can walk through what we do and try to see if there's a good partnership that we can start to build.
Absolutely. And, I offer the same to our listeners, right? As you guys are all along your journey in this discovery, here at EMI, myself in particular, happy to help. We're working with AirWorks and other companies just to show how beneficial these products can be. And we're, of course, happy to kind of guide you along the way. But Adam, thank you again. This was great. And we will catch everyone next time.
All right. Thank you so much. See ya.
All right. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you all the best in all of your engineering and technology endeavors. Thank you.